Hello everyone, my name is Samuel Breslin. I'm the Solar Gators electrical integration lead. And now I'm going to be doing a few videos on embedded programming, specifically with the STM32. Um, so yeah, I'm going to expect that you already have the STM32 Cube IDE downloaded. If not, you can just go to the STM website. It's free to download. I think you have to sign up for an account, but it's not as difficult to get as Altium. So yeah, this is the sort of start screen, and I'm going to go ahead and start a new STM32 project. It takes sort of a while to open up um, uh, the chip selector tool, which allows you to select what STM32 device you want to write your code for. Okay, so here is the selector. You have two options here. One is an MCU/MPU selector, and that allows you to select a specific chip that you're going to be writing code for. And you also have the board selector, and that allows you to select a development board that you'd be writing code for. For this, we're going to start with a development board. So I'm going to go and get, we use F072 development boards, Nucleo development boards. So go ahead and look that up, Nucleo-F072RB, and you can select the Nucleo F072RB here, and go ahead and click, that's annoying, it's fine. You can go ahead and click to next. I'm going to be creating a C project with the name GPIO example. C, go ahead and choose C and finish. And I'm going to initialize all peripherals with their default node. Click yes to the perspective. And that is, this is going to generate a lot of code for you. And I'm going to pretty quickly run through what this code is, what it generates for you, but not in too great detail. And then we're going to go ahead and write some example code for using GPIO, which stands for General Purpose Input Output. Okay, so this file that it opens up for you, the MX or .ioc file, is a graphical user interface that represents all of the pins of the STM and allows you to configure them to take up different peripherals. So to give you an idea of what a peripheral is, this here, everything we work with in STM 30 in this IDE is about this microcontroller, this STM32 microcontroller. Now inside of this microcontroller, you have your microprocessor, which is essentially your CPU. But a CPU is not very great at interfacing with the outside world. So to do that, you use peripherals, which allows you to use the CPU to interface with the outside world. One of these peripherals is GPIO. You have other ones such as your analog peripherals, such as your ADC, your analog to digital converter, your DAC, you have timers, you have all of your connectivity peripherals, like USART, USB, SPI, I2C, and CAN. You also have, but yeah, those are your main peripherals. So today we're going to be working with GPIO, which is by far the simplest one, mostly GPIO outputs. So you can see here the LD2 or green LED is already configured as a GPIO output. But if you wanted to do that yourself, you could go, we're going to make it reset state like all these other pins. We're going to go back to PA5 and set it to be a GPIO output. And we're going to head, and if you want to look at this in more, or not for now, if you want to look at this in more detail, you can go to System Core, GPIO, and you can see here, PA5 is configured as a GPIO output level low, GPIO mode output push pull with no pull up or pull down resistors, a maximum output speed of low, and all these sort of settings. So we're gonna go ahead and hit Control S, or sorry, and if it looks like it's not working for me because it's something I did earlier, but if you want to manually generate code, you go to Project, Generate Code, hit Yes. That's going to open up your main.c file and generate some code. So you can see under Core, Source, you have your main file and all these other files, as well as some other important ones under Inc or Include. And let's go to main.c. So here at the beginning, you have your header, you have your include statements, and this is important here, these sort of comment protectors. So you have user code begin includes, user code end includes. So if you wanted to make some of your own includes that aren't already generated for you, you have to write them inside of here. So you could say go include standard bool.h, and yeah, that would include, or I think it's that. Include standard bool.h. You have ones for all kinds of things, and then you have user code begin 0, user code end 0. Now the reason that these are here is because when you're generating code, say you wanted to go back to the IOC file, add more peripherals, and then regenerate your code, the software, this Cube MX or this Cube IDE, needs to know what code you wrote and what code it wrote, so it knows what to delete, what to write over. So any code that you do not write in these comment blocks, say you wrote your code out here, is going to be deleted when you regenerate new code. So you want to make sure that you're writing all of your code inside of these comment blocks, and they provide tons of these comment blocks, and I believe you can add more if you need. So next we have the private variables. Okay, sorry about that. So here we have our private variables. So this is the handle for the UART, which we're going to go get into later. We have some prototype function or function prototypes for system clock config, for GPIO init, and for USART init. And here we have our initialization of HAL, which is the hardware application library, which we're going to get into in a minute. You configure the clock, configure the GPIO, which this is what we're going to be talking about mostly, configure USART, and then this is our while loop. And so that's where most of your code is going to be running. Here is our actual function for the system clock config. We'll get into that a little later. The initialization function for UART, which we'll also get into later. And then here's the one we're interested in now, the initialization function for GPIO. So here we see some of the sort of settings for a GPIO pin. We have the pin number being pin, this is the one we're working with, being pin 5. You have it as a output push-pull, no pull-up or pull-down resistor. The speed is the frequency low. Those are all the settings we sort of talked about in the GUI, and you can configure these, and that would change the code that's being generated here. And then here's some other error handler stuff, and some comments. Okay, so we're going to really quickly write some GPIO code. So they give you sort of an example line of code here. Now, what this is you want, when you initialize this pin, you want to know what state it's going to be initialized to. And so this pin sets it to GPIO pin reset, which is low, or on an STM is going to be 0 volts. So high, or GPIO allows you to set a high or low output, which low is usually going to be 0 volts and high is usually going to be 3.3 volts or 5 volts depending on what microcontroller you're using. So I'm going to I'll write it out. Go up to our while loop, and in here, right, so now we're between the user code begin while and user code end while comment blocks. We're going to write HAL underscore GPIO underscore write pin, and then we're going to do the port that the GPIO pin is on. So GPIO A, because it's PA5, we're going to say which pin it is. So GPIO underscore pin underscore 5, and we're going to say, I believe we'll say GPIO underscore pin underscore set. There we go. So that is going to turn on the pin or go to 3.3 volts. Now we're going to delay the code. So HAL underscore delay. And then the first parameter is going to be the number of milliseconds you want to delay for. So we're going to do half a second or 500 milliseconds. Now I'm going to copy this HAL GPIO write pin function. And I'm going to do GPIO pin reset to turn the pin off. And then we're going to delay one more time. Delay 500 semicolon. And so that is going to turn off the pin and delay for half a second. And then it's going to go right back up to GPIO pin set. So let's see if this code compiles. We're going to go to Project, Build Project. And as you can see, the code compiles with 0 errors and 0 warnings. Now, say you wanted to write this code a little simpler, right? You wanted to toggle the pin on and off. Now, using, say, one line of code. Now, you could write a whole function that checks what the current state is and flips it to the opposite of that. But there's usually better built-in functions in the HAL libraries, which stands for Hardware Application Library. And that sort of allows you, the hardware application libraries allow you to write code that with only small changes is going to work between different microprocessors. So, and usually different microprocessors of the same family. So other, say, STM F0s, or even other STMs like the STM G4, things like that. So let's go to the HAL library, or STM32 HAL for the F0. So I have it open here. And we're going to go to the table of contents. It's really useful to use the table of contents for these because they're extremely long. This one is 1,400 pages. And we're going to look for the GPIO system. Let's see. HAL GPIO generic driver, firmware driver API description, and let's look at the detailed description of functions. Okay, so you have, this is the one we used, HAL GPIO write pin, you have HAL GPIO read pin, things like that. Here's the one we're looking for, HAL GPIO toggle pin. And this gives you everything you need to pass in as parameter. So you need to add your GPIO port, you need to add your pin, and you don't need your reset or set command because, right, we're just toggling it to whatever it is not currently. So let's go back to our code. We're going to comment out all of this. And we're going to write HAL underscore GPIO underscore toggle pin. We're going to do GPIO A and GPIO underscore pin underscore 5. Now, just to demonstrate to you that all these types line up, if you hover over this, you can see that this is a macro expansion for GPIO type definition with all of that. And you can see that is what this function is looking for. And then this guy is another macro for uint16 0x002, and that is what this is looking for, a uint16. So there we go. There's those two functions. So yeah, that is how you set up a project in STM and how you use your simple GPIO outputs. Thank you. Next video, I'm going to go over how to do how to use interrupts. So we're going to be looking at inputs and yeah, the interrupt system of a microcontroller, as well as maybe traditional how GPIO reads. But yeah, stop.